Hello again! You may have wondered why there are so many different part numbers for the isolated power modules from Texas Instruments. Today, I am going to get into the details as to why. One of the key drivers for the different part numbers is the isolation rating. The even numbers ending in 40 have a 3 kV RMS, or basic isolation rating. The odd numbers ending in 41 have a 5 kV RMS, or reinforced isolation rating. The other differentiator is maximum power. Here you can see that the maximum power delivery for the same output range varies as a function of the input voltage. This is most obvious with the UCC14xxx and UCC14141. These devices can support 3 different input voltage ranges, each with its own power limitation. One of the key culprits here is the integrated transformer. For the same input and output voltages, the distance between the transformer windings has to increase to support a higher isolation rating. The wider gap means the transformer has to be optimized to maximize efficiency, so for isolation alone, the transformer has to change to raise the isolation rating from 3 kV to 5 kV RMS. To support the different input voltage ranges, the transformer also has to change to optimize for maximum efficiency. Depending on the input and output range targeted, the turns ratio has to be modified accordingly. So, what about the power differences? Fundamentally, as the input voltage is lowered, the input currents increase. Here we are at the mercy of Ohm's law, where higher currents result in higher I squared R losses. Of course, there are also core losses in the rectification diodes and the source and sink of the output linear regulator. How these I squared R losses limit the power is a function of the ambient temperature and the ability for the IC package to get rid of the heat. The thermal resistance, or R theta JA, is 52.3 degrees C per watt. This means every watt of power dissipated by the IC will cause a temperature rise of 52.3 C above ambient. So why do these isolated power modules have a source and sink LDO at the output? The reason is that the secondary side can be configured as a single-ended output or a dual-rail power supply. This allows you to easily create a negative voltage rail to ensure the FET is disabled. So depending on whether you choose to use traditional silicon, SiC, or GaN FETs, the right isolated power solution for your gate driver is right here. Well, thank you for watching. I hope you found this informative. To see more, please like and subscribe.